Pluto, a captivating and enigmatic world, resides far beyond Neptune in the Kuiper belt. Once hailed as the ninth planet of our solar system, it was later reclassified as a dwarf planet in 2006. Pluto's unique orbit intersects with other planets, which doesn't align with typical planetary behavior. Yet, this reclassification didn't diminish the intrigue surrounding this celestial body. When contemplating the search for life beyond Earth, Pluto emerges as an especially intriguing subject. Recent discoveries on its surface and beneath its icy exterior challenge traditional assumptions about the conditions necessary for life. The stunning images captured by New Horizons and James Webb telescopes have surpassed expectations, revealing Pluto to be more than just a dwarf planet. This has left scientists puzzled as it defies conventional categorization. Exploring the secrets hidden within Pluto's subterranean depths promises to be a fascinating journey. But first, let's gauge your knowledge with a simple question. How does Pluto's size compare to Earth? Is it A, 1/3, B, 1/4, C, January 5th, or D, January 6th? Pluto, once considered a distant and inactive icy mass, now appears to harbor a dynamic and intricate subterranean world. The idea of a liquid ocean beneath its icy shell has gained traction, supported by evidence such as extinction fractures and the absence of significant craters in certain regions. This concept isn't entirely new. Scientific publications dating back to 1926 speculated about underground oceans in celestial bodies beyond gas giants, including dwarf planets like Pluto. The New Horizons mission provided unprecedented insights into Pluto's mysteries. Images revealed a landscape marked by fissures and a remarkably spherical shape, hinting at possible hidden complexities. Some scientists interpret these findings as indications of something even more extraordinary lying beneath the surface. Upon closer examination, researchers identified peculiar features such as the heart-shaped basin dubbed Sputnik Planitia, positioned nearly opposite Pluto's largest moon, Charon. Its alignment suggests a potential connection to an underground ocean. Models propose that the formation of this basin triggered the upwelling of water from beneath Pluto's surface. Subsequent freezing of nitrogen gas in the basin's frigid environment resulted in a significant shift in Pluto's alignment. Evidence supporting the existence of a subsurface ocean includes chaotic terrain on Pluto's far side, a jumbled landscape of ridges, cracks, and plains. Similar features observed on other celestial bodies suggest that they may result from asteroid impacts. To investigate further, planetary geologists like Aidan Denton simulate how such impacts could create seismic disturbances across Pluto. The research, presented virtually at the Lunar and Planetary Science Conference, supports the idea that a collision could have formed the terrain observed on Pluto's far side. However, there's a caveat. For such a collision to occur, Pluto would need to possess a subsurface ocean of liquid water about 150 kilometers thick. Oliver White, a planetary scientist at the SETI Institute in Mountain View, California, who created a geologic map of Pluto's far side, points out that while the terrain resembles features seen elsewhere in the solar system, the image resolution is low. Other scientists echoed this sentiment, emphasizing that until we can explore Pluto more thoroughly, uncertainties will persist. Nevertheless, Pluto boasts several geological oddities, notably a multitude of cracks discovered on its far side, supporting the notion of a hidden ocean and offering insights into its formation. The prevailing theory posits that Pluto's ocean initially froze, but later partially melted due to heat from decaying radioactive elements in its rocky core. This expansion and contraction likely resulted in surface wrinkles and cracks, with New Horizons images primarily showing cracks, suggesting the ocean started as liquid and gradually froze over time. One prominent feature observed on Pluto's far side is a massive crack resembling the East African Rift system. Unlike Earth's rift, Pluto's is likely a scar from the freezing and expanding ocean. Laboratory experiments suggest that Pluto's ocean might harbor organic molecules, supported by observations of red-tinted ice indicating the presence of organic matter possibly produced by solar wind or cosmic rays interacting with ammonia. This discovery, detailed in the journal Astrobiology, suggests that Pluto could potentially support life or at least provide conditions conducive to it. The revelation of organic material and the presence of liquid water on Pluto's far side are groundbreaking discoveries. This finding, coupled with the abundance of sunlight and temperate conditions in the region, provides compelling evidence for the potential habitability of Pluto's subsurface ocean. While these discoveries are significant steps forward, they also raise questions about the possibility of artificial structures on Pluto, as speculated by some UFO hunters. Some claim to have spotted suspicious features on the dwarf planet's surface, such as a mysterious smoky trail stretching 10 miles. While some speculate that this trail could indicate alien activity, NASA attributes it to a natural phenomenon. According to NASA, the 10-mile smoky patch is likely sunlight reflecting off a methane cloud. However, UFO hunters argue that this isn't a cloud but a massive smokestack rising from the surface, possibly emanating from a hidden structure on Pluto. Similar structures have been observed on Mercury and Mars, fueling conspiracy theories that NASA is aware of such anomalies, but chooses to conceal them. The far-side measurements of Pluto have generated numerous mysteries. Upon closer examination, scientists discovered bizarre terrain consisting of skyscraper-sized ice shards resembling blades towering as high as 1 kilometer above the surface. These features, observed on both the near and far sides of Pluto, are composed of methane ice and span a vast area around the equator. The origins of these bladed ridges remain unclear, with hypotheses ranging from methane freezing out of the atmosphere to erosion by sunlight. Another intriguing discovery on Pluto is the presence of a potential cryovolcano near the bright heart-shaped region known as Sputnik Planitia. The Kadzi crater, measuring 44 kilometers wide, appears to have spewed ice lava onto Pluto's surface through cryovolcanism, a process driven by heat from the planet's interior. This recent volcanic activity suggests that Pluto retains more internal heat than previously thought, possibly due to its hidden subsurface ocean. Research into Pluto's geological features continues to unravel its complexity. Most of its surface is covered with methane and nitrogen ice, adding to the enigmatic nature of this distant world. As scientists delve deeper into the data from the New Horizons spacecraft, Pluto's mysteries are gradually being unveiled, shedding light on its dynamic and evolving landscape. The distinguishing feature of the Kadzi crater on Pluto is the prominent presence of water ice around its perimeter. As noted by study lead author Dale Crank, a professor at the University of Central Florida, this water ice stands out distinctly from the methane ice that covers much of Pluto's surface. With Pluto's axis tilted sharply at 120 degrees, it experiences dramatic climate variations as it orbits the Sun. Methane ice on its surface sublimates into hydrocarbon haze in the atmosphere, which eventually precipitates as snow, masking the spectral signature of water ice. Scientists estimate that over Pluto's 4.6 billion year history, the methane ice layer must have thickened to at least 14 meters. A layer of organic smog just a few centimeters thick would obscure the water ice signature, suggesting that the Kadzi crater was active only a few million years ago. The mechanism behind cryovolcanic activity on Pluto remains incompletely understood. While the planet's small size would suggest that it lost all its internal heat long ago, one possibility is the presence of radioactive elements in its core, which could have provided heat through decay. However, previous research indicates there might not be sufficient radioactive elements to sustain such activity. Despite these uncertainties, Pluto's continued geological activity, coupled with the existence of a subsurface ocean, presents intriguing possibilities for further exploration. As scientists continue unraveling Pluto's mysteries, a new study proposes using the thickness of ice shells covering ocean-bearing moons in our solar system as indicators of potential habitability. Inspired by measurements of Antarctic ice shells, researchers from Cornell University suggest that variations in ice thickness could provide insights into the underlying oceans of these moons, such as Saturn's Enceladus and Jupiter's Europa. These moons are believed to harbor vast oceans beneath their icy exteriors, potentially conducive to life. However, detecting life beneath thick ice presents significant technological challenges. NASA is exploring concepts for future missions, including cryobots designed to penetrate these icy shells and explore subsurface oceans in search of life. With ongoing advancements in space exploration, the prospect of uncovering the secrets of these distant ocean worlds becomes increasingly tantalizing. The concept of a cryobot represents an innovative approach to exploring the icy oceans of celestial bodies, like Europa and Enceladus. Unlike traditional drilling methods, which may not be suitable for the colder and thicker ice shells of these moons, cryobots utilize a thermal drilling technique to melt ice as they descend through the subsurface layers. While similar thermal drilling techniques are employed on Earth to investigate glaciers and ice caps, adapting them for extraterrestrial environments poses unique challenges. Researchers supported by NASA have been developing cryobot concepts as part of the scientific exploration of subsurface oceans on Europa and other ocean worlds. A recent workshop held at the California Institute of Technology provided an opportunity for scientists involved in these projects to collaborate and incorporate the latest developments into future mission architectures. Water is a crucial component for life as we know it, making the presence of liquid water on icy moons like Europa and Enceladus particularly intriguing to astrobiologists. The workshop identified 4 key aspects: power, thermal capability, mobility, and communication, that are essential for the development of an effective cryobot for exploring these alien water worlds. Power is a critical consideration for a cryobot, requiring a nuclear power system capable of generating sufficient heat to melt through miles of ice. This system must also withstand the immense pressure of the subsurface oceans. Thermal management is essential to regulate the internal temperature of the cryobot and prevent overheating. In addition to environmental challenges, cryobots must navigate through potentially complex ice shells containing impurities, like rock and salt. Mechanical